Hello, so today this is our first video to help review Chapter 4, Graphing Quadratics and Factoring Quadratics and all the fun stuff with quadratic equations. So to review Section 4.1, we're going to take a look at graphing quadratic functions in standard form. So to do that, we're going to go to the chapter review on page 318, and I chose number 6 to take a look at. So the equation for number 6 is given to us as y equals negative 3x squared plus 12x minus 7. And as you can tell, this is written in standard form. Y equals ax squared plus bx plus c. So as you recall from when we first discussed section 4.1, there are 4 things I would like you to do when graphing a parabola written in standard form. The first thing I want you to find is the y-intercept. And the reason I'm asking you to do that is because this is a relatively easy point to find when an equation is written in standard form. And that's always given to us as the point 0, c. So for this parabola, that point would be 0, negative 7. Now, the second and third things are related. So we're going to find the vertex, and we're going to find the axis of symmetry. And then the fourth thing is we're just going to find another point to help us graph this parabola. Okay, so for the vertex and for the axis of symmetry, we need to go down here and do a little bit of side work. Okay, so in standard form, to find the vertex, you're going to use the equation x equals the opposite of b over 2a. So the opposite of b is going to be negative 12 over 2 times negative 3. So we have negative 12 over negative 6, which simplifies to positive 2. Now that gives us the x-coordinate of the vertex, and it gives us the equation for the axis of symmetry. To find the y-coordinate of the vertex, we simply substitute the x-coordinate into the function. So we have y equals negative 3 times 2 squared plus 12 times 2 minus 7. Simplifying the arithmetic here, we have negative 3 times 4 plus 24 minus 7. So we have negative 12 plus 24. Oops, we have a little mistake here. So let me erase that. So we should have plus 24 minus 7. So we should have 12 minus 7, which gives us a positive 5, and that is the y-coordinate. Now we need another point on this parabola, so I recommend using an x-coordinate that is close to your vertex that's easy to substitute in. So a point that's close to 2 that's easy to substitute would be the point 1. So we substitute that into my equation. We have negative 3 times 1 squared plus 12 times 1 minus 7. Okay, again, we have a little mistake there. So we have minus 7. So we have y equals negative 3 plus 12 minus 7. So we have positive 2. So putting this all together here, we're going to draw our coordinate axes. All right. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so first point we can graph is the y-intercept is 0, negative 7. So 1, 2, 3, 4, 5, 6, 7. And we can plot that point. Next point is 2, 5, 2, 1, 2, 3, 4, 5. And then you can recall the axis of symmetry is that imaginary line that goes through the vertex. Okay. 1, 2 is our additional point we found. And then now what we're going to do is play on symmetry. So if we know 1, 2 is a point, we also know 3, 2 must be a point on the graph. And the same thing for 0, negative 7, we must have the point for negative 7 on the graph. So we can plot additional points so that we can get a nice, relatively good parabola. And remember, we want to use shape when we draw the parabola. Okay. So identifying our points here, this was our vertex. This equation was our axis of symmetry. Okay. This was our y-intercept. Okay. And then these were additional points that we either plugged in or we used symmetry to find. And that is how we graph quadratic functions in standard form.